Hi everybody, and thank you for being here to listen about STAMP, this collaborative project. STAMP stands for Software Testing Amplification, and we will see what this is, this esoteric kind of software testing. And we will see how STAMP can let you to introduce, to empower the quality of your software. Using it, you can use it, of course, in DevOps is the natural usage of STAMP, but you can also use in more traditional software development processes. Just 2 words about me. I am a software engineering a software engineer for engineering group, and I collaborate with the OW2 community, chairing the technology council and representing my company in the board of director. And I'm a software test enthusiast. I teach several courses about it, and with my team we deliver best practices for our colleagues and customers and so on. I'm a member of the OW2 Spago4Q projects, and in STEM project currently I'm leading the work package 4 that is related to the system integration, the integration of STAMP artifacts. So in the agenda we will see what are the needs that STAMP want to address, the ideas behind STAMP, and how can use them just now, because several components are already available, of course some open source components. They're available in the GitHub, in a GitHub repository, and you will see. Let's start from the values behind the DevOps movements, columns: culture, automation, lean, measurement, and sharing. And let's focus on automation, because automation is a key point in DevOps culture and DevOps approach to software development. Yes, to automate, you need, of course, an infrastructure. Here you can see a representation of several tools that you can use within your software development process. And you see that there is a pipeline with several tools. Some of them you know very well, the GitLab, Jenkins, and a lot of other things. And it seems that automating everything could be the solution to deliver software faster, in time, and so on. But and deliver the value behind your software, because we develop software to deliver value to our customers, to our end users. But we can have a problem, because the real value behind our software is that it simply should work properly. And the risk that it couldn't work properly usually is mitigated with software testing. Software testing is a central point, is the main important things that you have to do to mitigate the risk that your software can work properly. A bad software simply fails faster when you automate everything, and this means that the quality, the value of your software disappear quickly, faster. Yes, there is an old saying in software testing that bad test only gives you bad results faster. This is true. Okay, so we have a lot of methodology that we can put in place, and we can consider to design our test cases using several approaches. This is one of the most famous, the test pyramids, where you have the base made of your unit testing. you usually have a lot of unit testing, then a few left integration testing, and then functional and manual and so on. And you know that's the cost typically rises going to the top of the pyramid. And related to the concept of test pyramids, you have the concept of bug filter. Usually, the test pyramid brings these effects to your developments. So the greatest part of your bugs are filtered by the unit testing. Then integration tests help you to remove several other bugs and so on. But sometimes some bug can escape from your filter and presenting it in production, so you have several stack traces in your production logs, and you know. How can we improve this filter? And if some bug escape, how difficult it is to reproduce it, to fix it? Because when you have a bug, the first thing you have to do, the first thing a developer have to do is to reproduce it and then to fix it. You can also put in place several other practices as test-driven development, because test-driven development lets you to write just the code that you need to implement the requirements. Usually in test-driven development, test cases are also named as executable specification. This is very important. If you think to a test case as an executable specification, you are more focused on developing just the software you need to implement that specification. And usually in test-driven development, you have two phases. So you write the test case, the executable specification, then you write the software to implement it. And when you have a successful test, usually you refactor, and then you have to iterate in this process. But is there a way to know how good are your tests? How good are your test cases to detect bugs? And another aspect you have to consider. We live in a heterogeneous world, so your software can use a Postgres database, a MariaDB, you can use several application servers, you know. And all these configurations can lead different behaviors into your software solution. How can you manage and how can you increase the coverage of your test cases in this heterogeneous world? The idea is the idea behind STAMP is to address all these issues in order to enhance the quality. So STAMP finds the best results in several parts in the typical DevOps cycle, but you will see that these concepts are applicable also in other more traditional context, okay? And so I will go quickly to the conclusion. You can have components that are able to produce variants automatically to your test cases. You can have components that are able to test your test. You can have components that generates variants of your test configurations. We will see how. These are a list of the main components developed at the moment in the STAMP project. You have, for instance, the cart. It's able to test your test, injecting variations in your source code and detecting how your test cases are able to detect that variation, that mutations. You have this pot, able to generate variants to your test cases. And Camp and Tecor are two components able to generate variants from your test configurations made with Docker files and execute your test cases against this configuration. And also EvoCrash. it takes production logs and generates a test case able to reproduce that bugs. Okay? And all these components can be used as standalone, but you can use also within Eclipse. There is an integration made by Ethos to use this spot within Eclipse. You can use the cart within your Jenkins pipeline, and it shows reports on how good are your tests. You can use camp to generate a variation of your test configurations and tcore to execute them. And these components can be used as standalone or within Jenkins pipeline, for instance. You have EvoCrash to reproduce test cases. Usually you feed EvoCrash with the production logs, and EvoCrash is able to generate new test cases to reproduce that bug. You can also try Stamp within a virtual machine, the Stamp Virtual Lab. So it's very easy to start with Stamp. And in this way, you can enhance your pipeline, putting Stamp components in several stages of your pipeline. Conclusion. If you want to try, of course, you can find several tutorials, but I think that the most important thing is that Stamp simply don't generate automatically software. No, Stamp needs, of course, that you design your test cases, and then it can enhance your test cases. Stamp requires that you design your test configuration, and then it will enhance and amplify and execute them for you. So at the moment, computers need humans, as well as human needs computers. And now we have several steps that we want to achieve in the remaining of the project, optimizing the source code, exposing Stamp functionalities as microservices, and adding more integration in GitHub, GitLab, Jenkins, and so on. You will see. So if you're interested, you can go to the official websites. You will see the references. The Stamp source code is on GitHub, and several tutorials are over there. Okay, thank you. If you have any question, I'm available.